AI has written over 30% of code in the Google latest products. Also, Nvidia's market cap has reached around 4.8 trillion US dollars. And 83% of companies say that AI is their top strategic priority. But here's the thing. Most people still can't explain actually what is artificial intelligence. So guys, welcome back to the channel. My name is Omar and I'm here to break down complex AI into bite-sized pieces for you to use and most importantly, understand. This video is essentially kicking off to a series that I'm going to be doing in regards to AI and AI security. Think of it as like a crash course before we go into the more advanced stuff. However, let's go ahead and start with the question that everyone actually pretends to really know, and that is obviously, what is artificial intelligence? Let's go ahead and start off with the simple definition, and that is AI is machines doing tasks that usually require human intelligence. However, that's the same way as, for example, saying that a smartphone is just a device for making calls. It misses 99% of what it actually is capable of doing or what it's actually meant for. So let's go over actually the real framework in terms of the definition of AI. AI is a decision-making system that learns from data, specifically not from hard-coded rules. It recognizes patterns the same way that you may recognize your friends' faces. It makes predictions, so for example, what's the next word that is supposed to be coming next, or what does this image contain? And also, most importantly, it gets better over time given the more data that is fed to it or the more examples. Think of traditional software the same way like a McDonald's kitchen. So it's the same recipe each time, therefore you're getting the exact same burger each time, especially if you follow the steps of the recipe. So it's just steps 1, 2, and 3, and you're always going to get the end same result. That's our traditional software. We are getting the predictable output. So AI is like a chef who's tasted thousands of dishes. So if you give them a bunch of ingredients, they are able to come up with a new dish based on patterns that they have already learned. There is no recipe actually required. Now, there's 3 levels to actually remember. There is ANI, AGI, and ASI. So let's start with artificial narrow intelligence. And that is just simply the model mastering one thing. And that is just could be, for example, a chess engine, let's say. Then you have AGI, so artificial general intelligence, and that is human level intelligence. So that across all tasks, and we are not actually there yet. And ASI, which is super artificial intelligence, and this is beyond human intelligence. And this is more of a, let's say, theoretical future state. So again, your ANI, your narrow intelligence, it masters one thing. Your AGI, which is your human level intelligence across all domains, and that we're saying we're not there yet. And then obviously you have your ASI, which is beyond the human capability, which we say is more of a theoretical situation. Let's just go over the evolution timeline of artificial intelligence and where does it actually come from. And believe it or not, this actually goes back to Alan Turing's time, which it was in the 1950s. And he was actually coming up with those questions and asking the things like, can machines actually think? This is where he ended up creating the Turing test. In 1956, the term artificial intelligence was actually born at the Dartmouth conference. And funny enough, scientists actually did predict that we would have human level intelligence by the 1970s. Well, there is news here, and as I'm sure you're all aware, they were quite off from that prediction, and we are actually still waiting. And then between the 1970s and the 1980s, this was the so-called reality check, and this was the winter for AI. There was no funding, it had completely dried up, and why was that? It's just simply because they were lacking computing power. I mean, the computing power that was around at the time was no stronger than the power within your microwave. They were able to write the algorithms, but they did not have the infrastructure to run them. Then the 1990s to the 2000s came along, and this is what people like to refer to it as more the quiet revolution. So IBM's Deep Blue actually ended up beating Kasparov at chess in around 1997. Behind the scenes in 98, you had Google PageRank come out, Amazon recommendations. This was technically a form of AI, it was just not called AI back then. And now 2010 onwards was where we call the deep learning explosion. In 2012, AlexNet actually achieves 85% image accuracy, beating the previous 74%. And there were 3 factors why this was actually possible. So you have 3 catalysts, and the first thing was the GPUs. So NVIDIA's parallel processing 1,000 times faster than the CPUs that we were reliant on before then. We had the concept of big data being introduced. So ImageNet actually had around 14 million images that were actually labeled. And then obviously the concept of cloud computing actually being introduced. So therefore people were then able to train models without needing the necessary $10 million worth of hardware. And then obviously I'll move on to 2017, which is a pivoting point and an absolutely critical turning point when it comes to artificial intelligence, which was the concept of the transformer. Now, the transformer architecture, when it was introduced, actually went ahead and changed the game completely. So the parameters that it was able to provide, so for GPT-3 was in 2020 was around 175 billion parameters, And now, as you guys know, we have GPT-5, and we're talking now over 2 trillion parameters. And you can see the exponential growth there. Just for a context, that is actually 10 times more connections than neurons that is actually in your brain. So if you can just put that into perspective, it is absolutely crazy what we've achieved. Another crazy milestone in terms of the history was November 2022, where ChatGPT only took 2 months to hit 100 million users, in comparison with other successful applications or services like TikTok that actually took 9 months. Now let's go ahead and actually talk about some key concepts when it comes to artificial intelligence. And one thing that I do love to always start with, but I also have another video on this where I go into more depth, is the hierarchy, where we talk about how does the umbrella of artificial intelligence look. So where I said you have artificial intelligence, then machine learning, then deep learning, and then a product of the deep learning would be something like the large language models, which is a product like ChatGPT, which we are all familiar with. However, let's look at machine learning versus AI. So AI is the goal, and machines are acting intelligent. So machine learning is the method, algorithms that learn from data, and deep learning is machine learning with neural networks, and that is obviously inspired by the brain structure, the human brain structure, that is. Now we have 3 learning types when it comes to machine learning, and that is supervised, unsupervised, and reinforcement learning. So to start with supervised, that's just simply like flashcards with answers. So imagine you're showing a model a picture of a cat, and it's labeled cat 10,000 times. It's going to learn that that picture or image is associated with a cat. A very simple example of this is obviously training Gmail on the spam and not spam filter by showing it spam email and labeling it spam as in the training data, and then showing it examples of not spam data. Then you have unsupervised learning, which is just simply like, imagine you've just given a child some Lego bricks, but you've not provided any instructions to them, so you're telling them to find the patterns themselves. A good example of this in the real world application is actually where Netflix goes ahead and they group viewers into viewing clusters, but without labels. And then finally, you have reinforcement learning. So this is just simply like as if you are training your dog, for example. So obviously, the right move or a good move is encouraged and reinforced with a reward, so a treat. And the bad move or any bad behavior is not encouraged or it is not rewarded. A good example of this is DeepMind's AlphaGo, and this actually played itself 30 million times until it beat the world champion. Now, just to go back to the revolutionary architecture, because this is a key concept that we have to understand, which is transformers, and why did they change everything? So previous models used to read sequentially, so that would be one word at a time, like as if you're using a flashlight. However, transformers see everything at once. That is like you've turned on the whole room light. Now, the amazing result here is the attention mechanism, and that gives the model context. So when the word bank is mentioned, it's able to distinguish, are we talking about the financial institution or the bank as in the river? And another good concept to understand is actually neural networks. Think of a neural network like a massive team of decision makers voting on an answer. Imagine you show it a picture of a dog, and the first layer of neurons are actually going to go ahead and look at the tiny pieces, so the edges, colors, and pixels. And each neuron will actually then go ahead and vote, I can see curves or I can see brown, for example. These votes then pass over to the next layer and they look for bigger patterns. So for example, it will start to say that, oh, those curves make an ear, or this brown is leading into fur. Layer by layer, the votes combine into more complex features. So ear becomes a head, then fur becomes a body, etc. And then the final layer will come along and it will announce something like, okay, this image is a dog, and I am 97% sure. Now here's the key thing, is that if it was wrong, so let's say that it called a cat a dog instead, we adjust the voting power, so the weights of the neurons that actually went ahead and led to this mistake. After millions of examples, the network actually then starts to learn what features or what things to look for actually matters. So if it says, oh, for example, the pointy ears is most likely it's going to be a cat. The floppier ears means it's most likely going to be a dog, and so on. So the training process is feed data, make a prediction, check error, adjust weights, and then repeat millions of times. For example, GPT-4's training cost was estimated to be $100 million alone in just compute power. So guys, that was the video. I know it didn't go into too much depth, but again, this was a high-level overview just to give you all a basic understanding of what is AI, the history and how it's evolved, and obviously some key concepts. And again, they were touched at a high level. I know some of my videos do go into more depth, but this is just because I do see that there's a lot of users out there, unfortunately, who have some misconceptions, not to their own fault, as it is something that can be quite confusing. If you did like the video in all cases, please be sure to like and comment below if you would like to see something else or something more specific or even different. And be sure to subscribe if you're interested in this type of content. Thank you.